Hello. Semtech audio. How are you doing? Okay. I think they should be here. All right. Let's see. 48 today. Share screen before I forget. Okay, so we are gonna do lab 5, and then I will post the DHCP lab. We will pick up where we left off with the server. So I want to introduce you to IPv6 a little bit. There will be lecture video that's going to come up, and if you do the assignment, you're going to learn a little bit more about how to use IPv6. As for most of you will be working with that currently, right? So you can find the lab here. It's not too long today. Okay, and then we can download that. So to start, let me see. Get this open. We can check out the lab, and then we'll start in about a minute or so. So Irene is gonna go, I don't know if you know Irene, right? Irene is gonna get an interview with Loma Linda. She's finished the assessment, and then I think David, and I hope everybody will be getting ready. But I'm working on a few more employers onboarding. Yeah. Now the RCC is also sharing our employers. But yeah, they have students are being hired as well. So it's good. It's the same district. So yeah. Yeah. I've been so busy in the last few days. It feels like fall is always so much more. We have to submit curriculum and get things through. And it's so crazy. But all right. So as you take a look at the lab, I'll just go ahead and get started because I think the people who are going to come, they're going to join us either on Zoom or in class in a little bit. So we'll start with just looking at our IP address again, right? Command prompt is your other best friend. Then we can do ipconfig /all. Let me change the font on this. We're not going to be in here too long today, but and so we are going to look at our adapter. That's going to be Ethernet, or you can also use the Wi-Fi as the Alienware has the Wi-Fi as well. Now we wanted to look, stay away from the virtual machine ones. Those are going to be a little different. So here you would see that the Ethernet adapter 6, the killer E2500, and your link local is going to be this. Okay. And then we'll take a look at the IP address. So in this network, they are using mostly IP version 4. We touch on IP version 4. We'll spend a little bit more time on subnetting in the next 2 weeks. But in this week, they started talking about IPv6 in the chapter. So here's your v6. Whenever you see the double colon notation, all that is just they are 0 between those. There are 0 digits here, right? And you only want to use a double colon once in your IPv6. You don't want to have them twice. So as you see this one, see how you only have them here? So that's called a shortened address. We can shorten because if you look at the version 6, it can be very long and all of those zeros are null anyway. So we can shorten them by just using the double colon. So in your assignment, there is a couple of things, a couple of questions that address this. So, and I would refer you to a website where it talks about how to write it correctly. So when you do the assignment, you get more familiar with it. The digits back here is going to be unique to the system, okay? And then we already talked about how the front of the address, the first half is going to be for the organization that creates the UID. So let's talk about this real quick. So when you take a look at your IP address, you want to record your IP version 6. In my case, right, this is my link local. And then I'm also using a DHCP version 6 as they have a server that's going to give out the IP address for version 6. You can enable this when you install the role where you would check that option for your DHCP, but they also use version 4. The reason why we do this is in an organization like this, you have old and new system. And so the old systems, when they communicate, they would use version 4, and then the new OSs would use both. So that way it would be smoothly transitioned. And eventually, maybe years from now, you will be completely on version 6. But for most part, you are going to see now in the workplace that you're going to have both. So we can take this and we can record it in our answer here. Okay. Does the network use the version 6 for DHCP? Yes. So we know that we are using version 6 DHCP on this network, right? And then let me Control C this, and I can, let me see if I can paste this. Okay. So you can copy and paste it over so you don't have to type it out. Now, does the server use the IP version 6 address? It should be using that, but you also have the DHCP server that is version 4. So there is an IAID for the IPv6 DHCP, and that's common. You're going to have this ID for the server that's going to be, so not technically not an address, but it's a way that we can identify it. So we can copy this. And then we can say yes. Well, it uses IAID. You can put that. So when you do migration from server 2008, let's say like an older server, to server 2016, for example, or 2019, you won't have the direct upgrade. So what you will have to do is, you know, when a lot of times we will have to migrate the files first, and then we would have to get all the Active Directory stuff in, and then we will have to transition in and set up the roles with the new, with the IPv6 separately. We test it and then we move everything in. So that's how you would do a migration for the network. How you would transition the upgrade in the OSs itself, because it's never a smooth process. There's always something that would go wrong. So you would expect, like, you would want to give yourself time and resources so that way you can handle those things, but you want to test it first, okay? So let's take a look at this. Let's say that we are looking at, so your prefix is going to be this right here, and that will be, so this is going to be your prefix, and that will be your site prefix. Then your subnet ID is going to be the one in the middle. And then the interface ID is going to be the last half. Okay. So when you look at this, if you look at the example here, what they have is you have 4, right, 8, 12. 12 of the front digits are going to be represented your site prefix. So that will be the specific to the site. So that will be the 12. As we already shortened the zeros there, right? So you're going to have the zeros that would fill in. So the prefix for our address is FE80000000 and so on, right? And then for your last half of the address, after the middle is going to be your interface ID. That will be like your host portion. So when we're saying that the site prefix and the subnet ID, this site prefix is going to pertain to your network ID, okay? And then your subnet ID is going to be like your subnet mask in IPv4. So when we look at the subnet ID here, I think I put this wrong. It should be your prefix. Your subnet ID is going to be, that's how it's going to zone in on what part of the network that will be. That's like your mask. And then your prefix is going to be your network ID. So it's going to be able to identify what part of the network that your system is existing in. Okay. So now what we want to do is we want to take this number, okay, FE80, and we want to go and access the site. I try to find a calculator that's easy to use for you. So what you're going to do is you are going to enter the prefix value here, the FE80. And then that's going to be the block of address that you want to use. Think of it like in IP version 4, it's like the 10.0. whatever. The network ID in the front, your first octet, right, for the class A is going to be this, right? But in IP version 6, there's no classes. It's just version 6. Now they have auto configuration. So if you want to do subnetting for version 6, you would use a calculator, because who's going to sit there and convert all the hexes over, right? Even though in the assignment I show you how you can do that, but then you would be able to select, and this is where you would choose the number of subnetwork that you want to use. So for example, if I have a very large company and I wanted to section it to many subnetworks, then I want to go with and these numbers are called CIDR, CIDR, right? And that was used in IP version 4 as well. So all that is we can section our main network into subnetworks, and we can divide it up. So let's say that if you have a lot of branches or many different departments that you want to really separate them, then you will be able to do that. So for a school like this, they might have like maybe less than 32, I assume, but it also depends on the number of systems in the per network and so on. So that will be the consideration. For a very large enterprise, you wanted to go higher, and the highest you can go is gonna be 64. Actually, yeah, more. So all of this is it's gonna be 2 to the n. So if I have 128 bits in the addresses for IP version 6, right? If we take 8 of that bits for the network portion, then we have the rest for your host. You see? So that means I have 120 bits. So what that will look like, I'm going to open up another. I love it when they use a second monitor. So let's say that if I choose /8, right? That means that I wanted to have, and it tells you here, I wanted to have one subnet, okay? So I'm gonna use that 8 bits for my network. So you're gonna then take 128 bits, which is the total number of bits in the IP version 6 address. You subtract the 8, which gives you 120. And so what that means is it's going to be 2 to the power of 120 for the number of hosts. Okay, and then you put that into your calculator, and you would see how many of the system different value of IP addresses that you're going to get. Okay, so it's just going to be the difference, right? Why is it 2 to the power of the difference? It's because it's binary, right? And because the computer, it sees it as binary, the bits is either on or off. So you would have 2 to the the n, which is the n is going to be the difference from the bit size. Okay. And you know, CCNA, they do ask more about this. I know Network Plus does ask a little bit. It doesn't really want to get in depth with this. I know that they do ask a little bit about IP version 4, but that's how you're able to determine the number of hosts. Okay, so and you would see a lot of calculator that would be like this. So if we select like 32 bits, okay, that's going to give us this many subnets. So it's 2 to the 32 power, which gives you what, like 160 something million, right? So if we want a very, very large network, like I'm talking about people that are doing worldwide stuff, right? Then we can actually select the higher bit size, because, and this is why they say that IPv6 is a better address, because you have so many different subnets to choose from, and you have so many hosts compared to version 4, which is limited, right? Even with subnetting. Okay, so once you do this, it should let you are you guys able to calculate it? Not able to show you that. Oh, maybe I didn't put in all the field. Let's refresh this real quick. Okay, so let's change this FE08 FE80. I'm sorry, FE80, and then we wanted to do a /32 and then choose 32. Okay. So your host address, you notice that this is like your .0, right? When all the hex, when it's on, it's gonna show F's like this, and then your notation is like this. So let's say that what if I have a different address, right? What if I have like 2001, like when you've seen some of the example, and then colon, and then let's say I use a 32, okay? Boo-boo, sorry. How is the format? It's the way that they program this. Okay, so let's change this to another value. Let's say 2001, like this. And we wanted to do a sub 30, right? And you can play with this a little bit more. So if you wanted to use this, and if you wanted to, so if you select the 32 bits, right, it's telling you it's one subnet, but what for this value. But let's say if I wanted to go higher, what if I wanted to do 64, right? And I would get a lot more, okay? So your subnet address, if we start with like a 2001, or we start with another value, then your range is provided here. And then your notation is always going to be that slash and then the bit size, okay? And you would see that it is multiple of 4, okay? When you select this, you would see that it's either, you know, it would start with like 8 and then go higher. So you can have, you would be safe to say that it will be a multiple of 4. Okay. So what does this mean for me? If I need to, and your DHCP, if you give it a range, it's going to auto configure, it's going to assign it. But what we can do is we can use this calculator to calculate our host ranges. Okay. And we can specify that in the DHCP, so that way it would be able to assign your host systems, which are your clients or other child domains or whatnot, if you wanted to really use this particular address scheme. Okay, so that's a way that you can use this. There are many different calculators. I think there are apps on your mobile for this as well. So all you have to do is to put in your network ID information or your prefix, and then be able to set this up. All right. Okay, so I just need a screen capture that you know how to access a calculator, and then what is your host range? So let's use the one for the school. What was it? FE80. Right? So this is gonna be, if I choose this for this particular network, right? I only gonna get, if I use 32-bit, I'm only gonna get one subnet on the out of that. Okay, and you can have the host range, that will be your address range, would be from FE800000 all the way to the end, which is when all the bits are on, which is FFFFFF, and it's in hexadecimal. Okay, so now what if I wanted to have more networks? Then I just have to modify the CIDR. Okay, so like I showed you, 64, right? And then we just choose, yeah. So for this prefix, you can't flex it too much there, the one that they're using. Okay, it's just like they probably just have one student network that's big. Okay. All right. Okay, any question? Mm-hmm.
Business, they decide to connect with you guys and they have more networks. Is it a big transition to?
Yeah, so, well, it depends on the scale. So let's say that if you have a medium-sized business and you have new investors and you want to expand to an enterprise, right? Like, and you would have, like, let's say we can say, because usually in IT, we would do prediction like for the next year, what is going to be your growth, right? Is it going to be 100%, 200%, 300%? So let's say that if the business goes 500% in growth, right? That means that if we have 100 system, we're going to have 5 times that, right? So what that means for us is we have to scale it from what we currently have in the facility. That means that you're going to have a lot more users, you're going to have a lot more data, you're going to have a lot more traffic, you're going to have a lot more stuff. So I would then extend it 5 times. So you have to take a look at your equipment. So if they have somewhat older equipment, you're going to have to say, is your, you have to look at how is your router handling it. Is your bandwidth is going to be valid for 500 times more? Probably not. So in that case, what you have to do is you're going to have to buy new equipment, right? Install additional servers to also handle that mass. And then for data and storage and, authentication and all of that, along with the wireless side that you're going to scale out. So in that case, a lot of times you would see like IT project manager, they specifically handle those things. And then your application, how's that going to scale, and the licenses. So it become a tremendous cost. And so an overhaul like that, it usually take a whole year. Yeah, for transition, because you don't want to just throw the system in and do it right away. That's going to fail automatically. So you want to gradually ease it in, right? Like I would put up new domain controllers and then transitioning it in. You know how they have single sign-on here, right? They probably planned it last year just for single sign-on, okay? Because a lot of the things need to be migrated for single sign-on. There's a lot more details going into single sign-on. So little stuff like that, like if sometimes it takes more than a year. So, okay. Any question with this? So yeah, with addresses too, right? You got to plan your network and your addresses and redesigning your network. So it's, but then the bright side is we want growth, because growth gives us job in IT. And in security, that's a big area too, because with growth means you have flaws, and with flaws means you have work. So yeah. Yeah. All right. So next part, we're just gonna do a network mon. This is something that Microsoft integrated. It's been there for a long time. Originally, it was used for server, but I think now they integrate it where you can use it on the client system. if you're familiar with Wireshark, it does the same thing. It's a sniffer, right? The interface wise, it's more user friendly, and it focuses more on your internal system, your local system, versus, you know, Wireshark is kind of like pulling everything everywhere unless you filter it down, and it could be a little bit challenging to use if you're not familiar with it, right? And you know that if they have a tool like this, that means that they have a CLI. Almost, you know, all Microsoft products, if you have a tool, that means that you can use it in command line. And so you can find like netmon commands, and then you can use it directly as a command line because it's designed for server. Okay, so you can go to the website, okay, and then we want English. That's what my friend would say. And here is where we can choose our size. X36 is the 32-bit. So you can use, you know, the 64-bit. So we can choose this and then click next. And then it just downloads. Now, there is another tool called, it's also network monitoring, but it's made by a company. It's open source. It's Windows friendly. The interface is really good too. You can also check those out. There are great open source tools, but you got to be careful about using open source for for-profit institutions or organization. You know, we can use it in education, but you know, in the license itself, sometimes it doesn't allow you to do that. So you have to ask for permissions and all of these other things. Now, if you do like a nonprofit, you might be able to ask for permissions, but for profit, usually you have to do donations and, you know, and all of that good stuff. So look at the licenses. And if you're not sure, refer to legal team, right? Ask a supervisor or someone, because you don't just take the liberty to install without, you know, we want to make sure that it's legitimate, because software auditing, you can get fined for a lot of things that is illegal, right? We don't use illegal software in a regular network. I had a former student that got hired for 2 days, and he used a pirated version of Windows OS, and he got fired after 2 days. So yeah, because he was just trying to be helpful and resourceful, but he just needs to ask, right? So you just do the typical installation, right? You can do the complete one if you want additional feature, but for us, we're just gonna need to do the basic. And this will take a little bit, and click finish. Okay, so almost all Windows tool, you have to run as admin. Otherwise, it doesn't give you all the full capability of that software at the system administration level, okay? So when you run it as a regular user, you're gonna find that you cannot locate the interface, meaning your network interface card to capture. The cool thing I like about this is you don't have to install all the NCAP, all the extra packages compared to other sniffer, because it's already using some of the existing services from Windows environment. Compared to that will be the native OS. Compared to Wireshark or other sniffer, you have to install the WinCap for Windows or the NCAP for other OSs. So it really depends on how they design the software. So once you have that installed, you can did it finish? Yeah, it's here. So it says Microsoft Network. Sorry, it may label it Microsoft Network. So we would search for Microsoft Network Mon, and you want to right click it before you run, and you want to choose Run as Administrator. And that's important because if you run it as a regular user, you're not going to be able to access all the network interface card and the adapter you have in your system. Okay. So they had gotten better with providing instructions and things like that for sniffer tools. I recall that when the industry was just really using this, not legitimately, it was you know, poor, right? Wireshark got better. A lot of the network monitoring tool got better. So here it talks about, you know, how to use some of the features, and you would see your interface on the left. Okay. And anytime that you need information or what to do, you would click help, and then it tells you how do I. This is like their frequently asked questions, right? So this is their form of documentation for the software. Okay. So what we're going to do is you can choose either the Wi-Fi or the Ethernet. So I'm just going to run the wired one first and see how that's going to be. So you can select this. So in your exercise, it tells you that you can select, after you do the installation, you run it as the administrator. And on the start page, you would select your adapter. And if you don't have the wired adapter, because I ran it on my laptop, you can choose the Wi-Fi one. Okay. So then over here, right? And then all you can do, you can also do a new capture, click this. And this is where you would be able to specify on what you're looking for. Okay. Your start page was what you've seen in the past. This is your capture one. And this allows you to create your filter. So if you do a load filter, you can choose your standard filter. And this is where we will see all the protocol that relates to our services. So I like this a little better than some of the other monitoring tool that's in the market or open source, that, you know, it is user friendly where you can click it, right? But it does handle the command inside the application as well, because it does have a CLI component. So if you want to filter by addresses, right? Every single network service is tied to at least one protocol. Okay. So, you know, like NetBIOS and so on. So we'll just do HTTP web page search. Okay. And why do I care about that? Well, I wanted to see how many of my systems are using web, right? On the regular basis. I wanted to have a baseline to really analyze like the traffic that's using for HTTP, not secured HTTP, and then I can also look at other things. So basically, it's just going to be for your web server here. That's going to search for the web server. And then once you have your filter in, right, then you can click start, and you only let it run for a few minutes. So what this will do, it's going to listen to your system first, right? It's going to see all the web application that I'm using. See, I'm using Zoom, right? I'm different than you because you might have other browser things that are open. So it's going to look at it's going to give you the information about that system first, right? So I had questions in the past, people asking me like, oh, you know, how do I know that if somebody is in my system? Well, scan your system and see, right? You should be able to see what kind of application that you're running, what kind of resource you're using, and who's there, right? It's kind of like putting a camera in your home and see who's there, right? So the sniffers does just that. It will tell you all the services and everything that's happening in your system and around your system. Okay, so here I would see, here's my traffic. Okay, so when you click that, what it will do is would actually sort it for you. It would say, oh, this is from that source, right? I'm looking at my system as a source. So, and all the timestamp here, right? And it's changing right now. So I'm gonna go ahead and pause this. Okay, so I can take a look. And I know that we've been talking about protocol, and in this week they re-emphasized the protocol again because you started to look at the header of your protocol. So all of these things are just logically designed so that way we can visibly see content of our network traffic, right? Which is ultimately just digital signal. So here what you would have is you do have some things that are unknown. Okay, and then you have all the web applications, and it would categorize it based on the known applications. So if you're having an application that's being jeopardized, you want to go look at that application, okay, to see, because sometimes they would embed things there and it would send out stuff to other sources, other server. I have a chat question. What is the unknown under my traffic? So the unknown is that Microsoft doesn't recognize what kind of traffic that is. It doesn't belong to any of the application that it knows. Okay. So things like if, you know, there are services that are connecting to my system for some kind of communication that will also send, and it's not browser oriented because all the browser oriented stuff is here, right? There are system resources that use communication to be able to support our OS communication. Okay, so here is where I would be able to see, could be for updates, right? We might have some updates things. It could be for, you know, application use, but it's not able to recognize what that application is. Okay, that's why it says it's unknown. And also, I sometimes would see, you see how all of these are UDP, right? The majority of your network traffic is going to be UDP. Even though we say that TCP is better, right? TCP is slow, right? The majority of the stuff that you see out there is TCP, okay? So the conversation that is given to you is here. It tells you like what is being requested, what is being sent. And SNMP, you already know that this is what simple, what network management protocol, right? It's a way that they do inventory and system management, and they can set this up through routers. They can set it up through server. So all of those systems are queuing your system and say, you know, who's in the network and what they're using. Okay, so this is why it doesn't recognize it, because those systems are pulling or communicating with your system to be able to manage it. Okay. And so that's what you see there. So in here, what we're going to look at is we are going to look at your applications that are listed, right? And so I'm running Chrome, I'm running Zoom, and I'm running a couple of things on Chrome. So when I look at that, I should have Chrome, and you can also click on the application and it tells you. So your browser, when you visit websites and things like that, see how you would have, and remember, we're filtering a lot of the things. We can filter down and we can take a look at the specific. So the web servers that it's connecting to, how it's keeping requests, there's keep alive acknowledgement, because, you know, it's got to make sure that there's time to live, and it has to live for a certain amount of time in order for that communication, especially for HTTPS, which is port 443. So I have Chrome, I have Zoom, I have Microsoft Word, which also uses, why do you think, like productivity software, why is it sending out traffic, you think? You don't know? Yeah, for stuff like images that you can clip into your Word document, that you can, you know, it can help you find, it can use dictionary that's going to be online. They do AI with that now, right? Like, so it recommends certain things to you, accessibility check. All of these applications are web supported, okay? If not web oriented. So, so why are you having all of these extra stuff? Well, there's extra stuff through your applications, okay? So now it tells you to look at your applications that are listed, what type of applications. So I can say that my applications is browser, right? And then I have productivity software because I'm in Word document. And then it depends. You can be gaming, and of course your game is going to communicate with the server and so on. I have a Word document open, but it's not listed under my traffic. Does it mean that it's not active, or what does that mean? Yeah, so if you're not signing it through Microsoft website, like Outlook or, you know, Office 365, then it doesn't generate any traffic, Michelle. So that's linked to your OneDrive, and it's also linked to like the features that we're using. So if you disable some of those features or not using those type of services, then your application doesn't send out things, right? And it's really depending on how we control it. Okay. All right. So then you're going to look at the system and then click on the IP address. You would see. So here's my system. I only have 4 things. Okay. And then there's the IP address. And it tells me, because I'm filtering HTTP, it's telling me that it's a browser, host announcement, server name. This is, you know, this is my system. Okay. That's my system name. That's your host name. Okay. And then this is the IP address. And there are 2 options there. So when you look at this, you see the frame detail, very similar to other monitoring tools, right? It would tell you, number 1, the interface that you're using. And when you highlight it, it actually highlight, right, the hex values that's equivalent to that. Okay. And then your source port, and this is for NetBIOS datagram. NetBIOS is commonly found in Windows environment anyways, that's resolving names to IP. Okay, so you can check out your frame. Okay, and then other things that we wanted to look at is other unknown that Microsoft doesn't know what they are. So you're gonna see ARP in here, right? ARP stands for what? Address Resolution Protocol. What does it do? Which address is where? Yeah, it maps. So Michelle said it maps IP to MAC address, right? So because eventually you're gonna have to get to the switch level, which is for the MAC address. Okay. And then your now, so for Network Plus, make sure that we know all of our common protocols, right? They don't expect you to know all the rare protocol, but the common ones like NAT, ARP, TCP, IP, all of the things that are listed in the book you need to know, right? And in networking environment, when you see SNMP, you automatically should know what it does, right? And so on. So here you're gonna see a lot of things that are gonna be for requests. You notice that if I look at one, it's gonna say that one system is gonna be asking another system, right, to resolve its, and that could be from your network, your system to that segment, right, that switch or a device. So it's asking for resolution there. And you're gonna see a lot of ARP traffic. You know that there's ARP poisoning in security. So you can capture that traffic, modify it, right? Okay, so here you would see ARP. And then you also have some M search here where it's seeking. And for your UDP, when you're looking at your UDP header, it's less, right? Even though they're all 32 bits, you're gonna have less content, and in the chapter it talks about that. So there's less field that goes into it, just source, destination, and a couple more things, and that's it. Compared to TCP, because it has to do the acknowledgement and then all of these other extra things, right? Your header is gonna be having more field. So it's gonna dedicate certain bits to certain area of that particular header. So think of the header as in like, okay, so there's TCP, you go to the post office and you fill out that form, right? Signature required when you receive this package. That's TCP header, okay? It actually tells on the form, right? You have to put down like, what's the weight of your package, right? How it should be put back together. That's how TCP is. But UDP, it's kind of like put a sticker on your box and then just throw it into the bins and they ship it out, right? Doesn't matter. If it gets there tomorrow or a month from now, it gets there, right? It's sent, okay? So that's how UDP is compared to that. But it's really fast compared to TCP where it does the 3-way, right? Are we communicating? Yes, we are. Okay, let's do it, right? So that's how it works. Now, so here in your lab, it tells you to take a look what protocol is listed with the IP address. Once you look at the system, we saw that earlier. And then you also need to take a look at your frame summary conversation for the console. So inside your frame, let me go back here. So if we look at the system again, right? So this, I only got the announcement. I didn't go too far, but it should tell me that this is a NetBIOS datagram right here. Okay. And it uses the port 138 for the datagram. And then the IP address. Okay. And your media type. And then sometime when you're using the Wi-Fi, you would see unencrypted data showing up, even though that you're on an encrypted area of the network. Okay. So we can say that this would be your NetBIOS. What is the source IP address? It would say source IP address. Okay. So here's your source. I have 10.151.101.254. And then the destination, guess what that is? That's a broadcast address, right? 10.151.101.255. And why is it using the broadcast? Because it's announcement, right? It's saying, hey, I'm here, right? This is it, use me, right? So yeah, so when you see the broadcast address and then the next to it, it should tell me the type of protocol. So when you have a protocol, you would have it piggyback either under the category of UDP or TCP. Okay, so for like broadcast type of traffic, you're gonna see UDP. Okay, and then for more secure things like HTTPS, you're gonna see TCP because it needs that reliable transmission. Okay, so you can take a look at that and you can record your answer. Now, if you have a Mac or a Linux, then you have to use another type of network monitoring tool. Similarly, you're gonna see packet information. It's the interface and selection options is different. Okay, so we got the source and the destination address recorded. Then you would look at the unknown list, and then you would view the frame summary, look at the conversation there, what protocols and ports are used in the frame. So let's look at the unknown list. There are lots, but mostly I would have UDP on mine, right? And then it depends on which you select. So the first one, I have UDP mostly for that conversation. On the second one, that's for network management. So I would have SNMP. And they're using version 1, right? In security, we look for the version that they're using because if they're using an outdated version, it could be that the device only support version 1, but if there's better version that they patch some of the things on the protocol, then we want to suggest that they upgrade the version, right? But it could be that the device that they're using only support version 1, but the newer devices, you can select the version of the protocol that you want to implement. We'll see when we do the routers. Okay. And then, so you can check out. So these are going to be also UDP. So the unknown one, you're going to see mostly SNMP and UDP there. Okay. Those are just a conversation for get, request, and reply. So my system is just asking for services, and then it would receive some kind of reply from the other system. That's all. Okay. Other questions? And then if we look at other traffic, we saw this a little bit earlier. We see ARP, right? And you also want to pay attention to the port that it's using for a certain protocol, because they're going to expect you to know which port to which protocol. So make sure you know the common ports. Like 53 for DNS, 22, right? For which port is that? 22. Which protocol? SSH, and what uses SSH? Secure file transfer protocol uses SSH. So we have to start memorizing protocols for certification purposes and practice. Okay. Okay, so when we look at the unknown list, right, the protocols and the ports that are used in the frame, you can take a look at the frame and then the source and the destination address. Okay. So here, let's pick the first one. I have UDP, and then my destination and my source. Then I have do you have any version 6? Did it record any version 6 on yours? No? Yeah, if you don't have version 6, you can just put none there. I was testing it with my home network and I implemented version 6, so it shows it. So it could be that internally in this local area network, they're not really fully supporting version 6, so you're not going to see it, right? But if you run this at home, you will find version 6 if your router supports it. Okay? So just put none, or NA is fine. Your media type is going to be your Ethernet adapter. That's the interface that you selected. And then if you look at the Wi-Fi one, if you try the Wi-Fi one, you will see unencrypted data in various frames. Okay. So we can say that no for the Ethernet, right? And then here is Ethernet. And the frame number that will be here. So before the packets become a packet, it needs to be framed, right? At the data link level, so it would put together, that's what the framing happens is at the layer 2 before it moves into layer 3 of the OSI. In the network level, for the third layer, you would see that it's mainly used for IP addressing and routing. But then in transport, it would revert back to the packet and also the protocols and the ports that's included in the packets in order to transport it to for the communication purposes, especially with TCP, right? So think of it like building a house. When you start, right, you have to have the foundation. So you have to frame the structure and making sure, and then in the third level is when you can fully start it to really put the rooms in. And then, you know, when it gets to the application level, then you can start, you know, living in the house. So the structure of this is, that's how communication, it's going to go back and forth between the top 2 layers, right? And then come back to, you know, the third layer again when you're submitting like for, you know, web services and so on. So in this week, the chapter talks about TCP IP model compared to OSI, make sure that we understand the differences. So TCP IP grouped up the bottom 2 layers into one, right? They call it network interface or network link. Is they combine the physical and the data link together. And then on the third layer, they kept the network the same. So there are several models out there, but the standard is the 4-layer model. Why would one have unavailable for other does not have unavailable under my traffic? I do not have unavailable. Yeah, so it depends on the type of services that you're using in your computer, right? In this particular network, so here it says, for mine, I'm looking at it now. So the process name, it's just not recognizing that process, Michelle. It's still executing that process. It's just the software is not able to identify what that process is. But it knows that it's using protocol, and it has a frame. Okay. How do you know if it's not malicious? You would check. So this right here, right? If I click this, this is inside my network. Okay. 110.151.101.254. So at home, you would then find out which system that is. You can, it should, if you ping it, it's just gonna reply, right? It doesn't tell you anything. But we can start narrowing down on which system that is. You can look at your router to be able to determine that, right? And then, you know, you can try to use command like hostname to see if it's, you know, or find that the IP to that hostname, what type of system that is. So you would look at your destination address, Michelle. Okay. All right. Okay, so on this, you will probably not see the ICMP traffic. But anyways, so look at the unavailable frame. That's just meaning that the software doesn't know what that process is. And then we're gonna look at other traffic, right? And on this right now, I don't have any ICMP. You know what ICMP is for? ICMP for? And right, so when it's checking, there are applications that regularly check to see if, you know, for things like downloading updates and things like that, like live updates, stuff. It's always going to try to communicate, right? So ICMP version 4, I believe, but you can do IPMC, you know, based on IPv6, it will say v6, but you can have ICMP just to see if the systems communicate. Okay. And it also depends on whether they turn it on or off. So if your firewalls block that, you're not going to see that traffic. Okay, so I don't have any ICMP on this, but you can check this out. You can run it on your home computer and see if you see stuff there. So you can learn a little bit more about your own home network and the traffic that's there. Yeah, you do have it at home. Yeah, your wireless router does that. So what the router does is it's advertising itself. That's how your SSID gets to all your systems, right? It uses that. So it's saying, hi, I am this, connect to me, right? That's ICMP. So if you disable the beaconing of SSID and you disable ICMP, then nobody can connect, right, without your control, and then nobody can ping. So just a way that it communicates with the system to see if it's, you know, it's available. So basically it does the for reply, the for request if you ping, and then your router does add the advertisement. So when you scan it, it's gonna say, oh, every 30 seconds, you're gonna see the router, or even sooner, sometimes less, right? It would say, hey, I'm this SSID connect. And that's how the wireless are by default. Okay. When you look at available network, that's how it is. That's what does it. Okay. A critical what?
That protocol, I don't know what it's for.
Oh yeah, but if you click on it, it will say the actual IP.
Oh, okay.
I'm sorry, a UDP or some kind of protocol. It
Okay,
uses,
oh, I see.
yeah, it uses UDP. It's just the software sees it as a browser, so it's an application, right? And then that application uses a certain protocol. Okay, so we should see ARP traffic. We saw that here, many. You're gonna see a lot of requests from your own system. And then you would see, if you look at the from a router standpoint, you're gonna see a lot of reply. Okay. So this is a good way that we can monitor our system traffic, and then you can look at the specific conversation, which is connection, right? It tells you source, destination, and then we filter it, remember, based on web search. So just like page search or connection via HTTP. And then the browser, if you click on that, you would see, right, what kind of protocol, the packet ID, and so on. Okay, now we can try another filter. So we can say display filter, low filter, you can do standard. And if you want, like, you know, you can customize this as well. So you can select, you don't have to select my recommendation, but you can do like for name resolution. If you have Active Directory or directory services, you would do LDAP to see how, you know, your system is connecting to that server or that server role for authentication. You know, authentication traffic, right? You can monitor that. And then if you're on Wi-Fi only, you can also listen to Wi-Fi signal. And then you can choose like for bad signal. So if we want a lot of throughput for the Wi-Fi, we would listen there.
We're worried about how much time you spend without your friends.
All right. Yep. Sorry. Yeah, I don't have speaker in this room, so. And then, you know, so you can set your filter and then you just click start again. Okay, so you can also save it because every time that you create a new capture, it saves it as a capture, right? And then you can save it to the system or you can export it out, just like all the other application. Okay, and then we can also do save as. Let's stop. So if you scan the stuff in here, you're only gonna see your pretty typical traffic for, you know, advertisement, respond, requests, things like that. Now, if we're looking for, so network forensic is a big area as well because it's part of incident response, right? You know, you might have this running live in the back and then it capture, you know, and then if there's a breach, you have to go in and you have to take a look at the capture and you have to identify that. But we do have tools for network forensic where we can just skim it down. I am not teaching 27A this semester, but we did do that for when I taught 27A. So it was pretty fun.
Why does it say, valid display filter?
When's that at?
So I.
They do TCP ports. Oh, yeah, so the port is 80. It didn't, well, it's not able to capture that. So remove that real quick. Oh, yeah, sorry, just low filter again. Yeah, so when it has conflict, it's when you have one filter over the other. Like you're telling it to keep this, but remove that,
Yeah.
but it needs both things at the same time, so it's gonna tell you that it can't do it. Yeah, but at the same time, you gotta make sure that those filters work together, right? Because if you remove something that is needed in another filter, then it's not gonna do it. Okay, so screen capture, and then that's it for today, actually. I intended to have more, but I said, well, give them time to play with this a little bit. And then we'll do DHCP on Thursday. Okay. And if you don't have Windows on this, at home, you can use the virtual machine. You can run this on your virtual machine. It works just as well. So on your virtual machine, if you want like to mimic your home network traffic, you would then bridge it, right? You just go to network and select bridge. You can use network address resolution. I'm sorry, network address translation, your NAT. All that is gonna take your virtual machine IP and convert it to your home network IP and then eventually the public IP. That works too. But if you want to isolate your virtual machine, then you just use host only. And ideally it would work, but so I gotta make sure I test the VM in here before. Okay. Any questions? How did you know the data is unencrypted? It will say it in the frame. Like when you click on the frame. So let's go here. Right? Yeah, when you use Wi-Fi, you would see a lot of it compared to Ethernet. It depends on the packets you're looking at, but yeah, so I'm in Chrome now. So it's gonna show that most of my stuff is gonna be like SSL TLS, which is encrypted traffic. But if you're connecting with another media for Wi-Fi, there's some part of it that the data is unencrypted. So the majority of, so your HTTPS, it capitalized on SSL and TLS, mostly TLS now, but you do have SSL, right? And that's where for your session. So, when you're visiting like those secure website, after you authenticate for your applications, you would see, so port 443, and then it would have a certain destination port. So for TCP, the flags are also important in your book and the notes. It also provide you with some flag information for the header. Okay, so make sure that we take a look at the flag information because Network Plus might ask that. It depends. It's a pool question, so you might get a flag question. So you guys know what a sequence number does? What's a sequence number does in the packet, you know?
Sequence number.
How it's going to be able to put it back, right? So because your data is sent in non-order manner, right? It's everywhere. And then TCP, when it gets back, it uses the sequence to check the order of your data and put it back before it presents it to you. Okay, so in the transport state, your raw data is not ordered. Okay, so at that layer, when it's transporting, it's just gonna send data. And sometime, you know, you would get the tail, right? The first and the middle, and then at the end, when it got the whole entire thing, it's gonna then use the sequence to put it back together in order and present it. And it also uses your packet ID to track the type of packets for that particular service, right? So all of these are used in a way for us to establish the communication from point A to point B by just looking at, you know, the services and the protocol. And we don't have voice over IP, but if you want to play with it, you can at home, you can like try to see if you can use like Google Voice or, you know, one of those, or, you know, Snapchat, where you can call inside an app and then scan and see. So when it's running through an app, likely that you're gonna see like HTTPS because it's through that app and authentication, but it also gonna piggyback like SMB likely, because, you know, like the same thing with Zoom, you're gonna see some of that for like conference based and you know, media based things. And then some of the app will also utilize like other type of communication. Is there an advantage of using network monitoring versus Wireshark? I think Wireshark is useful for listening to a lot of all of your devices at once. It's going to give you a lot of stuff in the surrounding more. So if you are scanning like additional everybody, then Wireshark is very useful for that. Now, if you're looking at your server and your services and all the things that you're running on that system, or the system that it's communicating to, then you would use network mon. Okay, so this application is useful if you're focusing on like that particular system or the systems in your domain, compared to Wireshark, you can scan everybody and everybody else. Now Wireshark has it is very useful, but it gives you a lot of data, so you have to know how to filter down your data and use it. I know they have certifications and books on it. You're welcome. And there are a lot of others too, right? Snort, things like that. So sometimes people prefer Windows systems, Windows tools. Okay, so I want to introduce you to some of the Windows tool, as we know that there are other open source ones. There are a couple good ones that you can use that's open source outside of Wireshark. Okay, So once you're done, you can submit and then you can hang out a little bit or you can grab a snack and enjoy your evening. Yeah, an hour and a half or an hour 15 minutes just flies by so fast.